A study reports that 68% of Americans support increased funding for public schools. If 3 Americans are chosen at random, what is the probability that all 3 of them support increased funding for public schools? None of the 3 support increased funding for public schools. At least one of the 3 support increased funding for public schools. So let's see. We have 3 different Americans chosen at random, and we want the probability all 3 of them support increased funding. So that would be the same thing as saying the first person chosen at random supports, and the second person chosen at random supports, and the third person chosen at random supports. So all of these probabilities can be joined with the word and, which means we're multiplying probabilities. So we're going to find the probability of each individual person, multiply them all together. Multiplication rule, then, we have to decide if we're dealing with independent events or dependent events. Our population here is all Americans, which is a very large population. So we're allowed to just assume independence, which means we can just take 0.68, which is the probability that one person out of the population supports increased funding, and raise that to the third power. So 0.68 raised to the third is 0.314. What's the probability that none of the 3 support increased funding for public schools? So the probability that none of the 3, what we have to do first is decide if the probability that someone does support public funding or increases in public funding is 0.68, and the probability that somebody does not support that, that is 1 minus 0.68, which is 0.32. So if 68% are in favor of it, then the complement of that is 32%. So the probability that one person does not support it is 0.32. The probability that the next person out of the 3 does not support it is still 0.32, and the same for the third. So in this case, we just need to take 0.32 to the third power, which is 0.033. And what's the probability of at least one of the 3 supporting increased funding for public schools? The probability of at least one. This is a rule that we're going to talk about in a little bit more detail later on, but it's complementary to the concept of none. And you can think of it like this. If you have 3 people, then either none of those people support increases, or at least one of them has to. Those 2 ideas are always going to be complementary, because at least one means one of the people do, 2 of the people do, or 3 of the people do. All of those qualify for at least one. The only time at least one doesn't qualify is when you have none of them. So since these are complementary, we can say 1 minus the probability that none of the 3 support, which we just found in part B, and come up with, let's see, 1 minus 0.033, which is 0.967.